Okay, for this last example, we're actually going to try and work backwards now. So we're going to try and figure out the equation based on what we see in the picture. Okay, now, theoretically, we could have an infinite number of answers here because periodic functions go on and on forever and ever and ever. So, and sine curves and cos curves are very much related to each other. So I'm going to get you guys to try and make one of each. Okay. The first one, I want to make a sine curve. Okay, the things we got to remember about sine curves are a basic sine curve is supposed to start at 0 and 0, then 90 and 1, and then 180 and 0, then back down, then back up. Now our picture looks very much like that, right? The only difference is it's moved up one. So if I'm writing a sine curve equation, I can do that pretty simply and say y equals sine x. Okay, there is no phase shift. It hasn't gone left to right. It literally has gone up 1. So I'll put it in the plus 1. That's my up 1. Now, if I wasn't sure about that, if I couldn't draw a picture on here, let's say, the other thing I could think about is that a sine curve is supposed to start on the central axis. The very first point is supposed to be on the central axis. The central axis for this one, I take my max, okay, I add my min, and I divide by 2, right? So if I did that, 2 plus 0 divided by 2 comes out to 1. I know that the central axis of this is at 1, which tells me my central axis is 1, right? That's kind of my giveaway right there. And then following that, I can look and see that, oh, it's doing what it's supposed to do. It's starting at 1 and it's going up like a sine curve is supposed to. Okay, so that's a couple ways you can get that sine curve. If I redid this, but I want to do a cos curve this time, y equals cos. Okay, a cos curve is supposed to start at 0 and 1. And then from there, it's supposed to go 90 and 0, 180 and negative 1, and then back up. That's what it's supposed to do. Well, ours definitely is not doing that. Our graph doesn't look anything close to that. But if I stop and think for a second, okay, here's that part of the cos curve. I can sort of see that there's been some translations happening here. It's been moved. It's gone from where it's supposed to the purple one, right? So what's happened here? Well, looking at it, looks like it's gone to the right and up. Okay, how do I show right and up? Well, I need an x and minus. How much to the right? Well, it's gone from here to there, and like that, right? So it's gone 90 right and up 1. Okay, and there's our curve. Now, the other trick we could do with cos curves is the maximum point is supposed to be your first point. That's easy to find at the max right here. If that point is not at 0 and 1, the difference between it is your transformation. So obviously, I've gone from 0 to 90, so that's how come I know it's a 90. And I've gone from 1 to 2, which is up 1, right? And that's kind of a tricky, quicker way of finding an equation there too. Okay, so try today's homework. A couple questions from the book to try. There's a quiz you can try again. It's got a bunch of multiple choice questions. Spin through a few of those, see how you do. And that takes us into that lesson.